Hello grade 10s and welcome to another video on exponents where we're going to look at grade 10 exponents, and this is what we are busy with at the moment in our class at my school. So you might be a little bit behind or a little bit ahead, but yeah, so when you get to this, hopefully it helps a bit. All right, so I've made a summary with the exponents just so that you know how to tackle these sums and what steps to follow, because when I was at school, I liked steps. So you tell me how to tackle something. All right, so with grade 10 exponents, step 1 is to make all numbers a product of its primes. Why do we want that? Why do we want prime numbers? So that we have the same base, so that we can multiply and divide, because the rule with multiplication and division with exponents is that you need the same base. You keep the same base and you add the exponents when you multiply, or you keep the same base and you subtract the exponents when you divide. Okay, so make all the numbers a product of its prime. So prime numbers are numbers like 2, 3, 5, 7, and 11. So believe it or not, all numbers are made up out of a combo of these numbers. Like if you take 144 for an example and you don't know the prime numbers, you can ask your calculator to help you. You put in the number, so you enter the number over here, you press equal, and then you press shift and fact. And when you do that, your calculator will tell you that 144 is made up out of 2 to the power 4 times 3 to the power of 2. So by doing that, we can get numbers with prime bases so that we can further simplify. All right, step 2 is get rid of all the brackets by raising the powers to a further power. So most of the times when there's brackets, there's an exponent on top of that bracket, and we raise the power to a further power. And please remember, like if you've got x to the power 2 raised to the power x plus 1, a power raised to a further power, you multiply together. Sorry, let me just make it a little bit bigger. And that 2 actually distributes and multiplies with both those exponent terms. So it's going to be x to the power 2x plus 2. All right. Step 3, simplify upstairs and downstairs. I always call it upstairs and downstairs, the numerator and the denominator by multiplying same base exponents. So if you've got the top, if there's x's with the power to the 5, x to the power 3, you're going to simplify those. And if you've got some y's over here, you're going to simplify them as well. And then lastly, you're going to divide up and down. So if there are anything that you can, if there's anything then that you can divide out with the same bases, obviously not those because they don't have the same base, but then you divide out. So step 1, let's just quickly go over it again. Make all the numbers a product of their primes. How do I do that? You can ask your calculator to help you by putting in the number, pressing equal, shift, and the fact button. The the factors button look like that. It's like a dot, comma, comma, comma button. Then step 2, get rid of all the brackets by raising the powers to a further power. And remember, if there's one term inside the bracket, it's everything inside the bracket is to that power. Step 3, simplify upstairs and downstairs. And step 4, then you simplify top and bottom together by dividing. Okay, but let's have a look at examples. All right, so let's have a look. Which numbers are not a product of their primes? So remember, prime numbers are like 2s and 3s and 5s. And at the moment, those two numbers are not a product of their primes. So I'm going to replace the 16 with a 2 to the power of 4. So equals to 2 to the power of 4. Now, that 2 on the outside is still over there. So it's 2 to the power 4 raised to a further 2. And the rest stayed the same. You could have simplified there already if you wanted to. Yeah, I'm going to simplify. These two bases are the same. You keep your same base and you add the exponents. And 81, written as a product of its primes, is, 81 equals shift fact. And it gives you 3 to the power of 4. So that is easy enough. Hey, so you make the non-prime numbers a product of their primes. Then we're going to further simplify. 2 to the power 4 times 2 is 8 times 3 to the power 2 times 4 is 8 over 2 to the power 12 times 3 to the power of 4. Okay, and then upstairs, there's nothing I can times with. Downstairs, no prime bases. So I'm going to go upstairs, downstairs like this. Finally now, pull your line or make your fraction line. 12 minus 8 is 4. Where did my power lie? At the bottom. And 8 minus 4 is 4. Where did my power lie? At the top. And then you are welcome to just ask your calculator. 3 to the power 8 divided by 2 to the power 4. 3 to the power of, sorry. Ayong, you must be screaming at me there from, it's 3 to the power 8 minus 4 is 4. Sorry, I wanted to say this answer didn't look correct. 3 to the power 4, which is 81, divided by 2 to the power 4. So it gives you 81 over 16. Okay, easy enough. I hope so. All right, over here, bringing some variables in, some x's. I just want to make this a little bit smaller. There we go. So a power raised to a further power, you multiply. We normally write the 4x first, the 4 instead of the x4, times 9 is not a prime number, and 12 as well. Sorry, so I'm just going to color it like that. The 9 becomes 3 to the power of 2. That 2, I always say, pushes up and it multiplies with that further power x. All over 12 becomes 2 to the power 2 times 3. Keep it in brackets because it's all to the power of 2x. Okay, we're going to deal with them now. So it's 2 to the power 4x times 3 to the power 2 times x is 2x over. Now, this is that rule where it says everything inside the bracket is to the power 2x. So the 2 to the power 2, 2 times 2 is 4x times 3 to the power of 1 times 2x is 2x. Now you're going to ask yourself, can I simplify upstairs? No, now we're going to look upstairs, downstairs, and they're actually all the same. So they divide out like that, and anything divided by the same something is 1. Right, let's identify those non-prime numbers, 16 and 32. So calculator, help me. 16 is 2 to the power of 4, all raised to the power x minus 1, over 2 to the power 4x times, and 32 becomes, 32 equals shift fact, 2 to the power of 5. Then this 4 is not just going to multiply with the x, it has to multiply with the x and the negative 1. So it's going to become 2 to the power 4x minus 4 over 2 to the power 4x times 2 to the power 5. And those we could have actually, I'm going to bring them together because they've got the same base. I keep the same base and I add the exponents. All right, so now in class, the students sometimes just get confused with how do I just drop it. So if I had x to the power 5 divided by x to the power 4, what did that become? It became x to the power of 1. Same as if you had x to the power 3 divided by x. What was your answer? X to the power 2. So can you see in each instance, I just dropped my fraction and just have my numerator at the top. I didn't put it over 1 or anything like that. So the same here. When you divide out with the same base, you keep the same base and then you subtract the exponents. So now you need to subtract this to the top. Okay, so minus 4. Now very important, sorry, I'm going to just stress that again. When you subtract, because it's no longer just one term that you're subtracting, it's 2 terms that you're subtracting, you have to put it inside a bracket. because that negative has to be distributed to the 4x. We have to minus the 4x as well as the positive 5. Now, at the moment, it might seem quite easy and say, oh, but why didn't I just say minus 4x minus 5? It's when that negative, so when this plus over here, this plus over here is a minus, then lots of you make mistakes. You say minus 4x minus 5, where indeed it should be minus 5, which makes it a positive. But we're going to get to an example like that. So we're going to have 2 to the power 4x minus 4 minus 4x minus 5, which then gives you 4x minus 4x is 0, and it leaves me with 2 to the power of negative 9. And that you can just pop into your calculator, and that gives you 1 over 512. All right, not so bad. Let's move on to the next one. Okay, here we've got the prime base is the same, and let me change one of these. Let me make that minus. Okay, so just to show you with these ones, I've got 2 to the power 3x plus 6 minus, because they've got the same base, I keep the same base and I subtract the exponents. Minus 3x minus 4. Then, if you didn't put a bracket, you're going to make a mistake there. You're going to say minus 3x minus 4, which in fact, because I've put the brackets, I can see clearly that it's going to be minus 3x, and a negative times a negative times a negative is a positive 4. Then we'll leave 3x minus 3x falls away, and 6 plus 4 is 10. And 2 to the power of 10 in your calculator gives you 1024. Then to the next one. Now we're going to get into the real numbers where it becomes maybe a little bit more tricky. So which numbers aren't prime bases? The 25 and the 125. So we need to make them the prime bases. 5 and 25 becomes 5 to the power of 2. That 2 pushes up, and that must multiply with the x and the negative 1. All over 5, and that's a 1 over there. Now, if there's nothing, there's a 1. And 125 equals shift fact gives you 5 to the power 3, and that 3 pushes up and it multiplies with the x. Then we've got 5 to the power x times 5 to the power 2x minus 2, all over 5 to the power. And can you see that we can write 1 plus 3x? Because we keep the same base and we add the exponents. Same with here. Keep the same base and we add the exponent. So x plus 2x is 3x minus 2, all over 5 to the power 1 plus 3x. Later on you'll see you'll maybe do it a little bit faster. You skip some steps. 5 to the power 3x minus 2 minus 1 plus 3x. Sorry, not skip some steps, but that you will just do it a little bit faster, like you don't have to rewrite everything the whole time. Okay, so then we've got 5 to the power 3x minus 2 minus 1 minus 3x, because a negative times a positive is a negative. So then the 3x and the 3x minus 3x falls away, and I'm left with 5 to the power of negative 3. And if you put that in your calculator, 5 to the power negative 3 gives you 1 over 125. Okay, not so bad. Now let's look at these ones. Not prime numbers. 18, 8, 9, and 4. Sorry, that was our bell that went. Okay, so 18 equals shift fact gives me 2 times 3 squared. And these ones are quite naughty ones because there's 2 prime numbers. that they are made up out of. Just remember that everything inside the bracket is to the power x. We'll do it now. 8 equals shift fact is 2 to the power of 3, all raised to the power x minus 1, over 9 becomes 3 to the power 2, all raised to x plus 1, and 4 becomes 2 to the power 2, all raised to 2x minus 1. So can you see that 18 I just went and replaced with whatever my calculator told me, and I kept the x at the top there. Same with the 8. All I did is I changed it into a product of its primes, and I kept the exponent x minus 1 exactly like that. Same with the 9. I just went and I replaced it with 3 squared, all raised to the power x plus 1. And the 4 I replaced with 2 squared, and it's still all raised to the power 2x minus 1. So that's very doable to do that. And then you just need to remember, or now rely on your grade 9 exponent rules to further simplify. All right, so now the grade 9 exponent rules are going to apply, where you say everything inside the bracket is to that power x. So 2 to the power x times 3 to the power 2 times x is 2x times 2 to the power 3x minus, so remember that 3 distributes and it multiplies with the x and the negative 1, so it's minus 3, all over 3 to the power 2x plus 2, very important, the 2 distributes to both terms over there, times 2 to the power 2 times 2 is 4x minus 2. All right, so now we're going to simplify upstairs. We're going to keep our same basis, so this one, oopsie, let me just, so this term over here can simplify with that term over there. So 2 to the power x times 2 to the power 3x minus 3 becomes 2 to the power of x plus 3x is 4x minus 3 times 3 to the power 2x, all over 3 to the power 2x plus 2 times 2 to the power 4x minus 2. All right, so now we're going to divide out. We're going to keep upstairs 2 to the power 4x minus 3, and we're going to subtract 4x minus 2 from the bottom, times 3 to the power 2x minus, and we're going to subtract 2x plus 2. Remember your brackets, because that forces you to distribute that negative correctly. Same with over there. All right, let's change the color a bit. So then you're left with 2 to the power 4x minus 3 minus 4x, and very important, a negative times a negative is a positive 2, times 3 to the power 2x minus 2x, and a negative times a positive, oopsie, times a positive is a negative 2. All right, so now let's simplify. Can you see the 4x minus 4x is 0? So it's going to be 2 to the power negative 3 plus 2, which is 2 to the power negative 1, times 3 to the power 2x minus 2x falls away, sorry, and minus 2. So at the end, you're going to have 3 to the power negative 2. So at the end, if I have to go and make them a positive, 2 times 3 squared, which will give me 9 times 2, which is 1 over 18. All right, let's look at number G. Now, the numbers that aren't prime is the 18 over there, and he is the only one that I'll need to change. So you're going to say 18 equals shift fact, and that is made up out of 2 times 3 squared, and that is all raised to the power x. Then over here in this bracket, the rule states everything inside the bracket is to the power 2. So we're going to start with a 2. Raising the 2 to the power 2 times 3 to the power, 1 times 2 is 2, and a negative x times 2 is negative 2x. All over 2 to the power x minus 1. Again, when we've got bracket and exponents, everything inside the bracket is to that power x. So it's going to be 2 to the power x times 3 to the power 2x times 2 to the power 2. You can make a dot or a times sign, doesn't matter. Times 3 to the power 2 minus 2x. All over 2 to the power x minus 1. Now we're going to clean up upstairs, and all the ones with the same bases you can multiply. So 2 to the power x times 2 to the power 2 gives you 2 to the power x plus 2. Keep your same base and you add the exponents. Times 3 to the power 2x plus 2. And now very important, a plus minus 2x becomes a minus 2x, or it stays at minus 2x. All over 2 to the power x minus 1. Then I'm going to divide out these two terms. Why those two? Because they've got the same bases. So I can divide out. So it will be 2 to the power x plus 2. And when you divide, you subtract your exponents. And over here, 2x minus 2x will fall away, and you are left with 3 squared. Then I'm going to rewrite it. 2 to the power x plus 2 minus x plus 1 times 3 to the power 2. And if you further simplify that, x minus x falls away, and 2 plus 1 is 3. So it's 2 to the power 3 times 3 to the power 2. And you're welcome to pop that into your calculator, and you will get that it is 72. Happiness. All right, now this one is a little bit harder. Why? Because we're working with fractions, a quarter. And the easiest way is, and I explained this to the class as well, if I've got 25, let's say 5 to the power negative 2. If I had that and I wanted to change it into a positive exponent, then I would have taken the 5 to the power 2 downstairs, and it will become 5 to the power positive 2. And if there's nothing left at the top, it becomes a 1, or you put in a 1 as a space saver. So it's 1 over 25. Okay, now how do I get this back to this? If I have 1 over, let's say, 16, can you see that 16 is becoming 2 to the power 4? Then to change it, 2 to the power negative 4. Okay, to keep it, to have it as a fraction with only well, not a fraction, but with a base number, that is that there's no fraction involved. So the same with 1 over 25. 25 becomes 2 to the power 5. Just make it a negative 2 to the power negative 5. Same with 1 over 9. 9 will become 3 to the power 2. Take it to the top, 3 to the power negative 2. If you've got 1 over 144, 144, let's try a smaller number, 1 over 81. 81 equals shift fact is 3 to the power 4. Then just say 3 to the power negative 4. So I hope you see when it is a fraction as 1 over something, you take that number, make it a product of its primes, and make the exponent a negative. All right, so hopefully that helps, so that we can understand this much better. So the quarter, the 4 becomes 2 to the power of 2. How do I bring it upstairs? I make it a negative. So it's 2 to the power negative 2. And that is all raised to the power negative 3x. Times 1 over 16 is 2 to the power 4. Times by x, because it's raised to a further power x. How do I make it a base number? I bring it upstairs, and I will make it a negative up there. So I'm just going to show you. 2 to the power negative 2 times negative 3x will give you 2 to the power negative times a negative is a positive. 2 times 3 is 6x times 2 to the power negative 4x. All right, you could have left it up downstairs and then just divide it out, but then you keep your same base with this way and say 6x plus minus 4x which will be 6x minus 4x, which is 2x. Okay, hope that makes sense. Over here, all right, so lekker, negative halves, a thirds. Oh, it's horrible. It looks worse than it is. All right, so first step is let's identify our numbers that are not prime numbers, like 27 and the 81 over there. So I'm going to change that into a product of its primes. So 27 is 3 to the power of 3. M to the power negative 1. And that all gets raised to a third. Times. This one I can do the power raised to a further power. I'm going to multiply, and you can just pop it into your calculator to see that it will give you m to the power 4 over 3. All over. 81 becomes 3 to the power 4 and m to the power 2, and that is all raised to the power negative a half. So don't stress about the negative a halves, weird exponents. We're just going to follow our rules. A power raised to a further power, we multiply together. So 1 over 3 times 3 will give you 1. So it's 3 to the power 1. Again, you don't have to write that 1. M to the power negative 1 times a third is negative a third, times m to the power 4 over 3, all over. Okay, power raised to a further power, you multiply. So negative a half times 4 gives you 3 to the power of 6, times, just want to make sure of that, negative a half times by 4 gives you negative 2. That's what I thought. Sorry, I punched it in correctly. So negative 0.5 times by 4 gives you 3 to the power negative 2. Times m to the power 2 times negative a half. So negative 0.5 times 2 gives you negative 1. Okay, so now can you see that the 3 and the 3 will cancel out? No, sorry. Sorry. That 3 is to the power negative 2. So I'm going to bring him upstairs as well as the m, so that I'm left with positive exponents. So it's going to be 3 times 3 to the power of 2, that one that went upstairs, times m to the power negative a third, times m to the power 4 over 3, times m to the power, and when he came upstairs he became a 1. So now we're going to change this 3 to the power 1 times 3 to the power 2, which is in fact actual fact 3 times 3 to either 3 to the power 3 or 3 times 9, which gives you 27. And then with this one they all have the same bases, so I'm going to keep my same base and I'm going to add the exponents. And all you're going to do is you're going to pop it into your calculator. Negative a third plus fraction 4 over 3 plus 1, and that gives you 27 m to the power of 2. Right, thank you so much for watching. I hope the exponents helped a bit, the exponents. So just remember, I'm just going to swipe it up to the top again where I show you the steps to follow. Jot it down into your books, make sure to follow them, and just whenever you get exponents, just remember prime bases. Why do we do prime bases? Because we want numbers, we want same bases. That's our whole aim, same bases, so that we can further simplify by multiplying and dividing. All right, so there's the steps again. And I hope you have a wonderful day further, and I'll hear from you in the next video. Have a great day. Bye.